Welcome. In this video, I'm going to teach you an example of using the law of exponential growth for a bacteria growth culture. So let's say the initial amount, not the initial amount, the bacteria, there are 100 bacteria in 2 hours. And then there are 1,000 bacteria after 8 hours. And then I want to find out how much bacteria after 10 hours using the law of exponential growth. All right. Alright, so the law of exponential growth says that y is equal to c e k t, and because the bacteria is growing in amount, in amount, we need k is going to be greater than 0, so we have growth. Alright, so we're going to come up with two equations. The first one is that after 2 hours there are 100 bacteria, so that means that 100 is equal to c e 2k, because there are 2 hours. In 2 hours there are 100 bacteria. And then the other equation is going to be 1,000 is equal to c a k. That means that after 8 hours, and then e here, of course, after 8 hours there are 1,000 bacteria. So we're going to use both equations to find c and k. Okay, so for this equation we're going to solve for c. The way we're going to do it is as follows. Okay, so we solve for c, we divide by e 2k and then e 2k. That means that c is equal to 100 times e, and then we bring that, so this cancels, and we bring the e to the 2k to the top by making it negative 2k. So there we have the equation for c. We don't know c, the final amount of the actual amount of c, but we do have an equation for it. Now we have here this equation. So what we're gonna do, we're gonna plug in this here. So 1,000 equal to e is gonna equal to 100 e negative 2k times e to the ak. We can divide by 100. This cancels, and we cancel 2 zeros, so we're left with 10 is equal to e to the minus 2k plus ak. Because we have the same base, we can add the exponents. So we have 10 is equal to e minus 2k plus ak, that's 6k. Taking log on both sides, left side stays the same, so ln of 10 is equal to 6k. We divide by 6, divide by 6, so k is equal to, you're gonna find that k is equal to 0.3838. Alright, so we have c, and we can find c by plugging in here because we already have k. So c is equal to 100 times e to the minus 2 times 0.3838, and that should give you a c to be equal to 46.4126. So we found C and K. Now we can plug it into the initial model. Remember, this is C. So Y is equal to C, which is 46.4126, and your K is equal to 0.3838T, where T is greater than 0. Okay, so now the final problem is how much after, so we have a model now. So now after at 10 years, how many bacteria we will have? We just plug it into T here and we're gonna get an answer. So Y, basically Y of 10 is equal to 46.4126, and then this is E, of course. This is E, and then 26, and then E, and then E to the 0.38, and then 10. And that gives us an answer of 2155 bacteria. So after 10, not 10 years, 10 hours, 10 hours. After 10 hours, we have 2,155 bacteria, because T is in years. Thank you very much. So first you find a model, then you plug in whatever approximation you want to get in years. That's all you needed to do for this problem. Thank you very much. Don't forget to subscribe.